Finding the domain and range of a graph. So being able to determine the domain and range when you're given a visual representation. So what you need to do is to think about it in terms of the domain is how far your graph, your points, whatever it is that you have on the grid, if it's points, if it's a shape, as in this case, a circle, if it's a parabola, whatever it is, you want to know how far it extends to the left and how far it extends to the right. So recall the domain is a set of all x values. So we want to know how far it extends on the x-axis to the left and to the right. The range, on the other hand, is how much this circle extends vertically, how much it extends up and how much it extends down. So this graph, its lowest point is at -6. The highest point is at 6. So therefore the range would be from -6 to 6. And when we write the range, we write them from least to greatest. So let's do some examples. Decide whether the relation defined by the graph below defines a function and give the domain and range. Does the graph relation defines a function? Well, first let's determine whether it's a function. Recall, all you have to do is just do a vertical line test, which means anywhere on that graph, draw or imagine a vertical line going through it. If it touches in only one place, such as it does in this case, then it is a function. So yes, we would define this as a function. And now for the domain. How much does it extend to the left and to the right? Well, anytime you have a line and a diagonal line specifically, here when you have it arrows on each end, that indicates that that line is going to go on in both directions to infinity. So in other words, to the left, this line is going to continue going on and on and on. And yes, it's going to go down, but it's still going to be going to the left, forever to the left. And it's going to be going forever and ever to the right. So therefore, we would say that the domain would be from -infinity to +infinity. And we always close infinity with parentheses. Always use parentheses when you have infinity on both ends. Now we want to find the range. The range is how much it extends up and down. And again, because you have arrows on both ends, it's going to go forever up and it's going to go forever and ever down. So therefore the range is also going to be from -infinity to +infinity, and that is always the case with these lines, whether you have a positive slope or a negative slope. It is going to have a domain and range of from -infinity to +infinity. In this next example, we want to determine whether the graph is a function and then find the domain and range. So let's go ahead and do the vertical line test. Recall that if we draw or imagine a vertical line through the graph at any point, if it touches in only one point, then it is a function. As you can see, it is only touching this graph in one point, at one point. So therefore, this is a graph of a function. Now let's determine the domain and range of the function. The domain, how far or how much it extends to the left and to the right. Now because this parabola have arrows on both ends, it means that it's going to go forever and ever on the left and forever and ever on the right. Again, because it has arrows, it's going to go forever on the left side, covering all digits, and forever on the right side. So therefore, the domain would be from negative infinity to positive infinity. The range, I want to know how much it extends up and down. So if we look at this parabola, we can see that the lowest point on the parabola here is -3. But because we have arrows on both ends here of the parabola, it's going to go forever and ever up. So the range then would be from -3 all the way to positive infinity. So recall with infinity, we always use a parentheses. Where the -3, we're going to use a bracket because it includes -3. And there you have it, the domain and range of this function. In this example, we're asked to find the domain and range of this function and to determine whether it is a function. Let's begin first by determining whether it is defined as a function. We're going to go ahead and do the vertical line test, which means to draw or imagine a vertical line through your graph. And we can see here that it is only going to touch or intersect in one point. So therefore, yes, it is defined as a function. Now let's determine what is the domain of this function. I want to know how much it extends to the left and to the right. As we can see that the graph will extend from 0. We're determining here our domain, which is our x-axis. And then it's going to go forever and ever to the right. So therefore, we would say that the domain of this function would be from 0 to positive infinity. So we're going to use a bracket where 0 is because it includes 0. And then recall that every time we write infinity, we use parentheses. Next, I want to know the range. The range is, again, how much it extends up and how much it extends down. Well, the graph does not go below 0, so it wouldn't include any negative numbers here. Your range would be starting here at 0, and because we have an arrow at the end of this graph, it means that it's going to go forever and ever up, even though it looks like you see it going to the right or to the side. It still is moving up to infinity. It still includes all your positive values because it has that arrow on the end. And up is all your positive, so it's going to include that. So it's going to be also the same as the domain from 0 all the way to positive infinity. In this example, we're asked to determine whether this graph is a function and then find the domain and range. So recall, to determine whether it is a function, we can do the vertical line test, which is to draw or imagine a vertical line through each part of your graph. And we only need to draw it once because what you notice is that you are hitting the graph twice. So anytime that your graph intersects, that the vertical line test intersects the graph in more than one point, then it is not a function. So this graph is not a function. Now let's find the domain, how much it extends to the left and how much it extends to the right. Well, we can see here in terms of the domain, the graph starts at -3, and then it's going to go forever and ever to the right. So the domain would be from -3 all the way to positive infinity. Make sure you close infinities with a parentheses. Where the -3 is, you're going to use a bracket because it includes -3. Our range, how much it extends up and down. Now, because you have arrows on both ends of your parabola, it means that it's going to go forever and ever up in the positives and forever and ever down into the negatives, which means that your range is going to be from negative infinity to positive infinity. In this last example, we're asked to determine whether this graph defines a function and give the domain and range. So first of all, let's go ahead and determine whether it is a function or not. All we need to do is to draw or imagine a vertical line going through our graph, and as we can see, it is touching or intersecting in only one point. So therefore, yes, it is defined as a function. Now let's determine the domain and range. Now be careful with this line. This is actually a line segment. Notice that it does not have arrows at the end, which means that it is going to stop and start at a certain point, that it is not going to go on to infinity. So your domain and range should not include any infinities. So now let's go ahead and find the domain, how much it extends to the left and how much it extends to the right. So as we can see here, on the left, my graph stops at -4. So if I go all the way to the right to see where it stops at 6. So that means that our domain would be from -4 to 6, and it includes those numbers, so we use a bracket. Remember, no infinity is used for this function. Now let's find the range. We want to know how much it extends up and how much it extends down. Well, the lowest point on this graph would be -3, and the highest point on the graph would be 2. So therefore, the range would be from -3 to 2. And again, when we write our numbers, we write them from least to greatest. And there you have it, finding the domain and range of a graph.